So, hi everyone, my name is Rohas Nagpal and I'm going to be talking to you about blockchain security 101. I hope my audio video are clear. So, I'd like to start with the absolute basics because I believe that's where we start to go wrong. When we are talking about security, let's start at the absolute first level. Now, when we talk about a blockchain network, which I hope you can see on my screen, it's visible, right? You see this red patch with addresses, ledger, and data written in the middle. Is that visible? Uh, Arnav, is that visible?
Yeah, your screen is
Awesome,
clear.
awesome. So I'm going to keep asking you, just keep giving me a yes, no, so that I know, it's all good. So when we talk about a blockchain, conceptually, this is what it looks like. Right at the heart of it is a shared ledger. That's right in the middle here. A ledger of transactions, which are being done by entities who have addresses. And then there could also be metadata relating to those transactions, which goes into this. So sorry. So, any blockchain, whether we are talking about Bitcoin or we are talking about Solana, ultimately this is the most important part of it, the shared ledger, the entities and the data. Now, how do we connect to this blockchain? So, a blockchain can have a large number of nodes, and logically, each node is supposed to have the same data. And I've set up a conceptual diagram here where let's say this is the running blockchain. These are all the different kinds of nodes around it. Now let's take this first example. So let's say there is a bank which is connecting to the blockchain for certain transactions. Now this is the node which the bank has connected to, and this is their internal network. Now in this internal network, it's a small diagram, but here you can see these are the users who are then connecting to the bank's internal networks, their web server, the sessions are being managed, everything is being done in a typical scenario here. And then this system connects to the blockchain through the API layer. Then there could be other nodes which are not connected to the network. So maybe this bank also has multiple other nodes are running. Although they are not connecting to it, they are still running the node because logically, the more the nodes, the more secure the blockchain becomes or the more decentralized it becomes. So this bank may run multiple. Then there may be another bank be doing a similar scenario. This may be a company again doing the similar scenario because in the blockchain world, we are not having a very uniform client base. It is a very hybrid client base. There could be all sorts of entities here. Then, depending upon the blockchain, you may even have admin nodes. So, suppose we are setting up like a permissioned blockchain. Even though it's a public blockchain, there are permissions here. Now, permissions need to be granted and revoked from time to time through admin nodes. So, that creates another new kind of a node here. In other systems, we may have validator nodes or mining nodes. Now, these are people who may not be doing business on the blockchain, but they are very critical to the blockchain because they are validating blocks or they are calculating the proof of work, and based on that, blocks are being created. And then there could be blockchain explorers. So, as we know, in every public blockchain, there will be an explorer. And through that explorer, anybody in the world, without even needing to log in, can see all the transactions, all the addresses, everything that is happening on the blockchain. So, naturally, there may be nodes doing that, which are then connected to a web server, which is then making it easy for anyone through a browser or a cell phone, whatever, to access all the real time data on the blockchain. So,
Sorry
this
to
is what.
interrupt you, sir. Sorry to interrupt you. Are the slides moving? People are
No,
not
no,
able
it's
to.
one. It's one only.
Okay,
Is it
so
not
is it
visible?
on the first slide? It still is on.
First was this blockchain security 101, and this was the
Actually,
red patch with
we
the.
cannot see the slides moving. As it's still on the first slide. The
Oh no!
blockchain.
Oh, that's really strange.
Yes.
Is it better now? I mean,
Yes. Now we can see that.
oh, I'll repeat. Then I'll have to just repeat. Yeah, give me a
Yes.
second. Yeah, yeah,
So,
no problem.
sir, would it be fine if you can keep this in presentation mode?
This mode.
A little bit enlarged.
Uh, Unfortunately, this is the maximum size is going. Is it not clearly visible?
I guess you can click the play button, so it will be on the full screen mode.
It is full screen right now.
Okay.
For me, it's full
Yeah. Then
screen.
yeah. Uh,
Is it not clear at all?
I guess, yeah, it is fine. I guess we can see it.
Okay, so now you're able to see this red patch in the middle.
Yes, yes. Now we can see that.
Okay, so let me give a quick recap.
Yeah, sure,
So,
sir.
as I explained, conceptually, a blockchain revolves around a shared ledger. So, when we talk about Bitcoin, the shared ledger is the ledger of all the transactions that are happening in the Bitcoin world. And each transaction would comprise multiple addresses, amounts, dates. So that is the ledger. These are the addresses which each entity has, and this could be metadata relating to transactions. This is not other normal data, like say in an NFT based platform. The actual high resolution version of the NFT is not going to be on the blockchain. That may be on a separate web server, or it may be on an IPFS system. But the metadata is going to be on the blockchain. So this is actually the core of the blockchain. And the entire function of all the nodes is to make sure that this data is provably immutable, and it is absolutely authentic, and it is visible to everybody all the time. Is that part clear? Any questions so far? A quick yes no would help me.
Not yet, sir.
Okay, awesome. Now there are nodes, right? So what does a node really do? See, a blockchain needs a blockchain framework. So Bitcoin is an example. So Bitcoin Core is a blockchain framework. Multi-chain is another blockchain framework. We need to install that on top of an operating system, which we're going to come to later. And that node which we spin up is going to be responsible for maintaining the blockchain or the state. And we can spin up more and more blockchains. And in many blockchains, the more the nodes, the more the security, especially in a proof of work kind of a scenario. But it's always better and more decentralized to have as many nodes as we can. Now, when it comes to connecting to the blockchain, let's presume that in our scenario, there is one bank here, which is bank A, another bank here, which is bank B, and a third one, say a company C. Now, this bank A is running this one node connected to the blockchain, and their internal network and web servers are connecting to their node through the API service. This bank may also run another node which is not connected to it. So it may not be used as part of the API, but just because they want to run multiple nodes, they want to add decentralization, they are also running nodes which are not connected to the network. All clear and visible so far? Yeah? A quick yes, no? Uh,
Yeah, the presentation is clearly visible.
Awesome. I'm sorry, I'll keep interrupting you because that's the only way I'll make sure that everything's clear. Right. So now, whatever transactions are happening, so let's say they are customers of the bank who are logging into the banking application and then connecting to their blockchain account. So this would become a scenario of a custodial wallet, kind of like how crypto exchanges operate, where your wallet is actually controlled by that centralized party, which is a bank or an exchange. And when you log in, it authenticates you based on the username password, and then transactions are actually pushed by that centralized party. So your private key is not under your control. Your private key is actually under the control of the bank. You authenticate through username password, and then the private key is used to sign transactions which are being pushed onto the shared ledger. Multiple other nodes which are doing nothing but except just helping to keep the blockchain decentralized. And that could be the case in bank A, bank B, as well as company C. However, there may be then third parties who are connecting to the blockchain and running their own wallets, which is what we would call as a non-custodial wallet where your private key is with you. So that means individual people could also set up their own nodes, which is an example here. Then there could be validator or mining nodes depending upon what consensus mechanism our blockchain is using. So in a proof of stake kind of an environment, we would have sorry, validators. In a proof of work, we would have miners. Now they are not really taking part in the transactions, but they are validating blocks, they are running all the mining services, so they are running their own bunch of nodes. Then if we are running a permissioned blockchain, even though it is public, it may be permissioned. There are various kinds of permissions which could be given, and that is where an admin node would step in to give permissions as well as to revoke permissions. And then we have explorers, which is where anybody in the world without needing to log in could actually connect to the blockchain, and they could view all the transactions in real time, see all the things that have happened in the past, and then there may be nodes running specifically to connect to this as a web service. So this is an overview of a simple blockchain. You can keep adding layers of complexity on top of this. There may be decentralized exchanges connecting, centralized exchanges connecting. Oracle networks could be connected here. And Oracle basically brings data from the outside world to the blockchain or takes it from the blockchain to the outside world. And and oracles can be inbound, outbound, hardware, software. So we can keep adding layers of complexity. But this is fundamentally what a blockchain looks like. All clear so far? Are there any questions on this layout?
Not yet, not yet, sir.
Okay, now I want some inputs from the audience. Right now, just by looking at this, can you tell me some of the attack points or the vulnerabilities? Where could they arise from? In this simple model, where all do you think things could go wrong? Anyone wants to take a shot? Has anyone put in any comments or?
I think not yet. No one has done that. Mhm.
Would you like to add some points here?
No, actually, no. I'm actually going through the model itself. Yeah,
Okay,
but I'm figuring out is somewhere related to a validator itself. Like,
mhm.
what if the validator itself is a malicious validator or the
That's one
miners,
very good point. Yes, that's a very
right?
good point.
And
So,
someone,
how
and
do we
someone has
plan to?
given,
Yeah,
yeah, yeah. So someone has also pointed out some API endpoints.
yes, very good.
Someone has pointed out, Shubham has, okay, Prajwal has pointed out the API endpoints.
Excellent.
Shubham, Shubham has pointed out between blockchain and Oracle's data.
Perfect.
And Shashank has pointed out running malicious node.
Perfect.
So these are the things that we
Yeah.
got till yet.
Excellent. Excellent points.
Mhm.
So, this API service, if you realize today in most blockchains, there are third party API services. So let's take an example of Bitcoin Core. So Bitcoin Core has its own APIs, but then that's not very easy to use. So people build third-party API on top of that. And what if there is a vulnerability in that API service? Because these API service could be even hosted by a third party. And then what is happening is this bank here, their internal software connects to a third party API running on a third party infrastructure. The third party then connects to the blockchain. So if something goes wrong at that end, or there is a man in the middle kind of an attack, and you've actually ended up connecting to the wrong kind of API service, you are exposing everything. Especially in a custodial format, even the private keys could get compromised in that situation. Then at the validator level, yes, you could have malicious validators. Now, many blockchains try to control that by putting a monetary fine. So, when you are in a proof of stake kind of a system, you stake certain crypto. And then if you have been found to be malicious, your crypto can be confiscated. But if the amount you're losing is less than the profit you're making because of hacking the network, well, then you would not bother and you would actually go ahead with that attack. So that creates another level of problem. And everywhere you see connections, there's another issue which could arise. Another man in the middle attack could happen here, where even if it is your own API service, what if your node has been compromised? Now, this is one of the biggest myths in blockchain. We always say that all nodes have the same data. First of all, that's not always true because every node is not syncing all the time. So let's say for whatever reason, this node of ours goes down for 1 hour. When it spins up again, first it has to sync all the data of the last 1 hour. So at that point of time, you did not have exactly the same data. Secondly, our nodes are hybrid. They are all not going to run the same operating system. So we may have some nodes running on Linux, some on Windows, some on Mac. All the nodes may not even be patched properly at the same time, which means some nodes are actually more vulnerable than the others. So if somebody was to break into this node and put malicious transactions, this bank would automatically start believing in the malicious or fake transactions. Whereas this bank, their node has not been compromised, so they actually have the authentic data. But how would this bank even come to know that its node has been tampered? They would never realize that, and they may end up believing in transactions which are actually not true. Any questions? Is this concept clear to all of you? You think there are any other attack points, methods that we have missed out so far?
Not yet. Davis has pointed out like What if the internal network itself is
Excellent point.
Mhm.
Excellent point. So what if now
Yes.
there is an attack here?
Mhm.
So I told you that in a custodial wallet scenario, the bank is maintaining your private key and they are authenticating you using username password. But what if somebody through phishing gets your username password and logs in? There is no way for the bank to know that the wrong person is logged in. The bank system says this is the username logged in, this is the private key related to him. So if this username pushes a transaction, automatically the private key is used to sign the transaction. There is no way for the bank to know that the wrong person is giving it. And immediately the transaction can be carried out. So you're perfectly right. There could be an attack, a conventional attack at this level also. Excellent point. Anything else you guys can think of?
Uh, Not yet.
Okay,
I guess
awesome.
yes.
Awesome, but I hope you've understood that when it comes to blockchain security, the blockchain element comes much later. Conventional security is a much bigger issue in the beginning.
True, true, true.
Now I've changed my screen. Has it changed? Does it show the word conceptual on top?
The slide has not yet changed. Yes, now it has been changed.
So that means in this service, you need to first exit full screen, then change the slide, and then come back.
Yes, might
Now
be.
can you see this layers
Yes,
and the word conceptual?
yes, conceptual. Yes, is
So
there.
now I am showing you conceptually what a blockchain node looks like. In the previous diagram, we saw how the nodes fit into the overall scenario. Now let's take it to the next step. At the bottom of any node is going to be an operating system. And this could be anything, any flavor of Linux, Windows, Mac. We need to first of all make sure that it is hardened, which means the basic security is put into place for that particular operating system. Now here, I mean, there are huge checklists which I could talk to you about, but one of the first things that we would do is in this operating system, we need to make sure it is updated. So every flavor, every operating system, all the time there are updates coming in as and when new features come out, are rolled out, or even when security problems are found. So we need to firstly make sure that our operating system is constantly updated. Secondly, we need to make sure that the root logins are disabled so that people are not able to log into the node with root permissions because that's not needed. Because if something goes wrong, it's a massive attack on the node which could take place. So we need to set up another user with lower privileges, which is going to actually create the framework, connect to the blockchain. We need to make sure proper firewall is in place. We need to block ports. See, a computer has 65,000 plus ports, but we don't need all of them. There are only a certain number of ports needed depending upon what that node is going to do. So if your node is going to run a web service, well, you need port 80 open. If it is going to run FTP, you will need 23 open, for example. If it is going to run an email service, which usually you shouldn't be running an email service on a blockchain node, but say your use case requires it, then only you would open those ports. Otherwise, you would make sure all those ports are shut and only the bare minimum ports needed, only they are kept open. Any questions so far? Is it all clear?
All good, all good. Just somebody has pointed out that it is better to not go full screen because the slides get stuck.
But right now, is it clearly visible to
Yeah,
all of
yeah, right now it's
you?
fine. Yes.
Now that we have this in place, let's talk about the blockchain framework. Now, you have to actually set up a blockchain, right? So, for example, when we talk about Ethereum, so Ethereum is not a blockchain. The blockchain's name is mainnet, and then there are a few test nets. Ethereum is the protocol, which is very similar to say HTTP or HTTPS, like Hypertext Transfer Protocol, Post Office Protocol, Simple Mail Transfer Protocol. Ethereum is a protocol. It has its own framework that we need to actually install. Bitcoin Core, we can install. Similarly, I've taken an example of multi-chain. We need to actually install that. And that is the layer where the framework is actually put. And we must remember, blockchains don't have their own operating systems. At the end of the day, they are like regular applications. They need an operating system on which you are going to then install them. So that becomes our blockchain framework. And obviously, if there is a vulnerability in the framework itself, that opens up a massive security hole. And I'd like to give an example. Like many people say blockchains cannot be hacked. That's not true. People say Bitcoin has never been hacked. Again, that's not true. I think this was about way back in 2010. Of course, Bitcoin was very new, but there was a protocol level vulnerability which was exploited, and the hackers managed to create billions of bitcoins, billion with a B for Bombay. Now you'll be surprised that Bitcoin is only supposed to have 21 million at most. How is it that they managed to create billion? Well, unfortunately, that was a vulnerability which was exploited. Then, I think in a few hours, the vulnerability was patched, and then the blockchain network had to undergo a soft fork. Everyone had to update their OS, I mean, sorry, their framework, and then those malicious transactions were actually rolled back. So, yes, blockchain level frame problems do happen. Let me give you another example of Ethereum. So you may remember, I'm not sure the year, maybe 2016 if it was, when the world's first DAO was set up, decentralized autonomous organization, and somebody found a flaw in the smart contract and they managed to siphon off a huge amount of ETH. Now at that time there was a question, what do we do? In a blockchain world, you can roll back transactions if you do a hard fork. Everyone didn't agree with that. I also think that was a wrong thing to do because blockchains are supposed to be immutable. If you roll back transactions, how is a blockchain immutable? Tomorrow, malicious users could also roll it back, but it was decided to roll back. People agreed, some didn't agree. So the Ethereum blockchain hard forked into two, and that is why today we have Ethereum with a native token of ETH, and we have Ethereum Classic with a native token of ETC. And ETC did not roll back. Ethereum rolled back those malicious transactions, and people got their funds back, and that is how the blockchain split into two. So that those are issues that happen at the blockchain framework level. Another example of a hard fork would be when people wanted to upgrade Bitcoin. Segwit technology they wanted to introduce, they wanted to increase block size to make Bitcoin transactions faster and cheaper. Some agreed, some disagreed. Bitcoin had a hard fork, and that is why we have Bitcoin and Bitcoin Cash, two independent blockchains which have the same addresses, and whoever held Bitcoin at that time was given an equivalent number of Bitcoin Cash at that time, and the same address works. So those are the issues that happen at the blockchain framework level. Any questions? All clear?
No questions still yet.
Awesome. Then we talk about the keys and the assets. So, in a blockchain, we need to set up a wallet. What is a wallet? A wallet primarily comprises your address to which people can send cryptos, your private key, which is what you would use to sign transactions to move your cryptos out. So, to receive the cryptos, you don't need to bother, you don't need to do anything. People can send it to you. But to move them out, you need your private key. So usually, the signing keys are usually on an algorithm called ECDSA, which stands for the elliptical curve digital signature algorithm. And there could be a problem at that level. We haven't seen one yet, but from time to time, these algorithms become redundant. So, for example, when we talk about hashing algorithms, ECDSA is a signing algorithm. Hashing algorithms, the world at one time used to use MD5. Then MD5 was attacked, and it was shown that it is too weak now. The world moved to SHA1, which was subsequently attacked. I think by Google was one of the first to prove it. The world moved to SHA2. We have SHA512. But a time will come when even SHA512 becomes redundant, because as computers become faster, we need to keep upgrading the hash functions that we use. So that is another level of problem that can arise when it comes to the algorithms that are being used. But all blockchains are designed in such a way that these things can be updated once the blockchain is running. So in a blockchain, always remember there are two kinds of parameters. One which are called runtime parameters. We can keep changing them even when the blockchain is running. And certain things we cannot change. So those are things that, like something as core as whether the blockchain has a native token or not. That's not a decision that you can change. Once you take a decision on yes or no, that can never be changed in future. But parameters like hashes and all can be changed in the future also. Any questions?
Not yet. Yes,
Okay.
but yeah, that is like very true. And we are now facing quantum computing issues as well upon these elliptical curves and like encryption algorithms, signatures, and all. Yeah. So yes, as you pointed out, this will be obsolete at some point of time, and we have to look forward for some new solutions, right?
Absolutely. Then we have the next thing, which is the assets. Now, again, blockchains can be of two types. One which only supports one native asset. Classic example would be Bitcoin. And then there could be blockchains like Ethereum, mainnet, where you can come and create as many tokens as you want. So, in fact, that is usually the distinction between a coin and a token. In a Bitcoin, since there is just that one native token, we call it a coin. In the Ethereum mainnet, there is a native token or a native crypto called ETH, which is a coin. But when you go and create tokens on it, for example, BAT, basic attention token, that is called a token because it is not native to the blockchain. It is created on top of the blockchain, but not native to it. So ETH is a coin, BAT would be a token. Now, when we create these, or you can create NFTs or whatever you want, ultimately, these are cryptos or assets, and these assets have their own permissions, and a lot of this comes out of the smart contracts, and if there is a vulnerability in the smart contract, that can be exploited. So a classic example again goes back to is the DAO, the first DAO, decentralized autonomous organization. There was a vulnerability or a mistake in the way the contract itself was written, and that led to the hack. So usually, a lot of us would use Open Zeppelin kind of services where they have developed open source smart contracts, and you can just tick a few buttons. It creates the smart contract which you can then deploy. And because these are created by experts around the world in an open source kind of a thing, they're usually considered to be extremely robust. But again, there's a limit to how much configuration can be given to you in a ready-made template, and that is why then people need to make their own customized versions. And if those are not audited properly or secured properly, then they could create a massive problem, and you could have a layer, an attack at this level. All clear? Any questions? Yes,
All
no?
good, sir. All good.
Awesome. Awesome. Now that we've taken a look at these three, then comes the API layer. So, like I said, Bitcoin Core has its own API, but then we want added functionality. So, an example of multi-chain, which took the Bitcoin Core and then built their own API layer on top. Then you have an example where even though you are running the node, you are using some other third-party API service. So that is ideally what comes at this level, and it has its own set of things that could go wrong. The APIs are not created properly, authentication is not done properly, if the API is not handling credentials properly, if there is an attack at the API infrastructure provider level. So all those are the kind of problems that could happen at the API level. Then finally, you have the applications and UI. See, at the end of the day, for the end user, it has to be simple to use the API or the blockchain. So he will need web and mobile applications. Now there are hazard things that could go wrong, and that's conventional. Just because it is a blockchain app or a DApp doesn't change the security implications. No matter what is the app, at the end of the day, you're going to use more or less the same programming languages, the same front end, the same back end, the same kind of databases. A lot of people don't realize, but in every blockchain app, you are going to have conventional databases also. You are going to have HTML, JavaScript, you are going to have a lot of conventional technology pieces, and they have the same problems across the world. So those also need to be tackled, and if we don't tackle them, it compromises the security of our application. Questions?
All good. Good to go.
Awesome. Let me now again shift to the next. Has the screen changed?
Yes.
Yeah, okay. So now let me tell you about the three basic kind of attacks that happen. And I mean, I've been talking about cybersecurity. So I started my career as a hacker in the early 1990s. And I think since then, we still talk about just these three attacks. So one is a man in the middle attack, another is a phishing attack, and the third is a spoofing attack. And there are some elements which are common to all three. So let's take a very simple example of a man in the middle attack. You're sitting at an airport, and now you want to connect your device to the Wi-Fi service at the airport, right? So you are now supposed to connect to the router. Whether it's a coffee shop or an airport, the scenario is the same. Is the same in your house also. But how do you know that you are connecting to the correct router? It is possible for someone to launch a man in the middle attack where I mean, you set up your own service which pretends to be the original service. Everybody connects to you. So I mean, at one time we've done this on Gmail. I don't know if it still happens on that, but you are logging into your Gmail account, The moment you enter your username password, instead of going to Gmail, it goes to this man in the middle. That man in the middle copies your username password and keeps it, but also passes it on to the actual Gmail servers through the proper router. Gmail authenticates and logs you in. The data flows, the man in the middle copies and keeps a copy of your emails and also passes it to you. So you as an end user didn't even realize, because this whole thing took a fraction of a second more. So you did not realize that your data is now being streamed somewhere else also, because you are able to log in and see your own email account. And the same thing you can apply to a DApp, you can apply to an online e-commerce kind of a shopping scenario. Everywhere a man in the middle attack can be carried out. And honestly, I've been seeing these attacks for decades now, and they're kind of still as easy to pull off as they've always been. And another misconception people have is that SSL doesn't allow this to happen. Not true at all. You can very easily spoof and duplicate SSL certificates, and the end user doesn't realize what's actually happening. Any questions on this?
Nope, all good.
Awesome. Phishing is the term which we use when you get a fake email, but you don't even realize it's fake. It'll have a link, you click on it, and you end up compromising your credentials. So I remember getting an email from, I'm not sure, I think it was MetaMask, and it looked very official. The URL also from where the email was coming looked pretty official, and it said there is some problem with your MetaMask, so please enter your recovery key phrase into it. Now, obviously, I realize it's a fake email because MetaMask doesn't know who you are. You have never given your email address to them. But that's the beauty of it. A lot of people don't realize this and they trust these emails. In fact, it happens in social media all the time where you get fake emails from Instagram and you end up clicking on a link and entering your username password and it gets stolen and your account is hijacked. The same kind of things happen in the crypto world also. So that's another very important thing that you need to be careful. And it's just user education. There's nothing else you can do. Any questions?
Not yet. Yeah, but yes, it happens with everyone.
Yeah, absolutely. And the third is spoofing, which is kind of like very similar to man in the middle and phishing, because you got to realize, how do you know you're getting the correct applications? Let's take an example of MetaMask. What if you ended up downloading MetaMask from a fake site and you don't even realize, but you've got a compromised MetaMask and it actually opens a back door? Or any app that you download, many fake versions exist. You may go to Google Play Store, but you may end up getting the fake app, and that happens very, very often. And that's another issue. So in fact, that is why the Brave browser now has its own crypto wallet, but you don't need to download an extension. The Brave browser itself functions as a wallet. So their logic is that because it doesn't require you to download extensions, it makes you less vulnerable to this kind of a fake app download attack. So I would strongly recommend, do consider using the Brave browser as your default browser, because it has its own crypto wallet also built in. And plus, of course, it's an amazing project, no doubt. Any questions?
All good, sir.
Okay, I'm going to change my slide. Let me know if it's visible.
Yes, it's good.
So as we discussed in the beginning, just to give you an overview of that, we saw that attacks can happen on multiple levels. The most common levels that we need to figure out and be careful about is the nodes. We talked about all the different kinds of nodes and the vulnerabilities and the attack points. We talked about wallets. Primarily, wallets are of two types: custodial and non-custodial. Custodial is where your private key is with someone else, dangerous. Non-custodial, where your key is with yourself, but you could face the danger of downloading the fake wallet. Someone phishes you and you end up giving the credentials to someone. Someone hacks into your computer, does a man in the middle attack, they could still end up compromising your wallet. And third, of course, we saw at the API, UI, UX level also attacks can take place. Now, let me go to the last slide. Is it visible now? You see a bunch of logos of different blockchains.
Yes, it is visible. And so Prathamesh has asked one question. Uh, like when we send some data or transaction over blockchain, so he is asking, like, isn't it encrypted, or like is it still affected by man in the middle attack?
Good. So it's a good question. See, a man in the middle attack even takes care of encryption, because what we've got to realize is, how is the encryption happening? So suppose I am the user and you are the bank, Now, between your website and my browser and your web server, a connection has to be established. So SSL handshake happens. Now, when this SSL handshake is happening, it requires me to communicate certain data and you to then calculate and send certain data, and a session key has to be generated. But the point is, in a man in the middle attack, the data sent by you is stopped by the man in the middle. He stops your data and then creates his own data and sends it forward. So the bank doesn't realize that it is not dealing with the correct person. The man in the middle appears to both sides to be the genuine guy. So encryption is happening, but the decryption key is with the man in the middle. Logically, the decryption key should be with you and the bank, but the real decryption key is with the bank and the man in the middle. And that is why even if it's encrypted data, it doesn't make any difference. Secondly, blockchains by default do not encrypt data. Encryption is supposed to be done at your traffic layer where your browser or the SSL layer would actually take care of it. The blockchains don't by default do that. Hope that answers your question.
Hope it does. I'll tell you if he asks another question.
Any other questions?
Not yet. All good.
Okay. Okay. Now, the last thing that I'd like to talk about is, so as a blockchain architect and developer, I've worked across these 16 blockchains. Let me just briefly talk to you about them and maybe from a security aspect also. So, what I like about Algorand is that Algorand is, they've got features of permissioned blockchain in it. So that means if suppose there has been some kind of a crime or a hack, and we feel that certain addresses are having the stolen tokens, then you can actually quarantine the assets. And the beauty of that is once you block that address, it cannot transfer that token out. So then you can do your investigation and do a forced transfer. And the crime can be rolled back without the need for a hard fork. So of course that does make Algorand kind of a permissioned blockchain, but then I think it has its own plus points also. If you have any questions, I mean, you can keep interrupting me. So that's one of the good things about Algorand. Any
Right.
questions?
Yeah, not yet. So, yes, that is nice in terms of Algorand. What in terms of public blockchains? What would be your recommendation to follow for
Sure.
general user?
Sure. So what you must remember is that Algorand is also a public blockchain. So I have actually, in building my own hi-fi or hybrid finance blockchain, we've taken features from many different blockchains. What is the definition of a public blockchain? I think a public blockchain means where the data is visible publicly through, say, an explorer. A public blockchain can be permissioned. So Algorand data is publicly available, so I can call it a public blockchain. Because it has permissions which can be controlled, I would say it is a public permission. Whereas we could say Bitcoin is a public permissionless blockchain. So are you getting the difference in what I'm trying to say?
Yes, got it, sir. Got it.
Yeah. So from a permission perspective, blockchains can be of two types, permissioned and non-permissioned. And blockchains can be of three types, which is public, private, and hybrid. So those are two very distinct things to look at. A private blockchain wouldn't allow anyone to see. Public blockchain would allow everyone, and hybrid would kind of have a mix. So that's usually in a consortium kind of a scenario
Mhm.
where you use different frameworks.
Right. And we have one more question. Someone has asked, what about some monitoring tools, some smart contract monitoring tools, kind of giving us alerts like in case of attacks that happen. So what are your views on that?
You are an expert in smart contract auditing, so I think you should answer that question.
Right, right. So I will definitely be reaching out to that guy and explaining all the smart contract stuff and all. And yes, another question is I realize that comes with the centralization issues, but regardless of the centralization infrastructure, is it possible? I guess he's referring to the same monitoring tools. I guess for the nodes as well. Can we
See,
have some monitoring tools?
sure. One thing we've got to remember is blockchains are not centralized, decentralized like we think. Do you know that Bitcoin, more than 51% of the mining power or hash rate is actually controlled by three pools? So
True.
I've written
Yes, sir.
an article which is
Right.
available online, and I've shown with statistics. Bitcoin highly centralized, Ethereum highly centralized, Binance highly centralized. So it's actually a misconception where we think that all these blockchains are very decentralized. That is not the case at all. Having answered that, yes, you can do a lot of node monitoring because you can set your own node. And then on your node, you can have a lot of monitoring tools which are running, and that doesn't go against the concept of centralization or decentralization. Definitely, analytics can be done very easily. And in
Mhm.
fact, a lot of the explorers, they are doing a lot of analysis for you. Hope that answers your question.
Right. Yes. That answers the question.
Sure.
And yes, all good.
Okay. Then there is Avalanche, one of my favorite blockchains. What I like about it is anybody can create public blockchains, private blockchains on top of Avalanche. You will use their consensus mechanism. You will use their native token, but you can run your own blockchains. Another great thing about it is the speeds are phenomenal. So transactional throughput, if you look at, if I recall, it's about 4,500 TPS, if I'm not mistaken. And Bitcoin 7, Ethereum is 14, Polkadot is I think 1500. Avalanche gives you 4,500. More important figure than transactional throughput is the transactional finality. Most people don't realize the difference in the two. When we are calculating TPS, what do? We take the number of transactions that can go into a block divided by the block time and we get TPS. But that is not the important thing. Transactional finality is important. In Bitcoin, 60 minutes is transactional finality. Once my transaction goes through, I don't trust it till 60 minutes. Anyone knows why? Anybody? Why do we wait for 60 minutes in Bitcoin? No one has an answer?
No answers from the audience.
Okay. So, we say that every 10 minutes a block is formed in Bitcoin. Approx 10. Sometimes blocks can take a minute, sometimes 20 minutes. Now, what happens is it possible at the same time different miners have properly mined blocks? Yes. So, suddenly you realize the blockchain is split into 3, 4. And another block gets mined, and again, there are still 4 different blockchains running. After 6, the network automatically looks and sees how many blockchains have formed, deletes all, and leaves the longest to run. And that is why there are chances. Of course, I've oversimplified this explanation, but there's a video I've made on blockchain basics on YouTube. You can check that out. That explains how it actually happens. So there are chances that your transaction went through in the beginning, but 60 minutes later it was cancelled. And that is why we wait for 60 minutes before we trust a Bitcoin transaction. In Ethereum, we wait for 6 odd minutes. In AVAX, Avalanche, in just seconds, we can trust the transaction that will not go back. So that is the importance of transactional finality. And in that respect, I would say Avalanche is the number one. Any questions?
Yes, Shashank has asked, so if we make a new blockchain using Avalanche protocol, will it be considered as layer one or layer 2?
It would still be considered as layer one. Excellent
Mhm.
question. It's still layer one.
Okay, got it.
Then we have Binance. So Binance started as a crypto exchange and the token, and then they set up their own blockchain. The original blockchain, which was called Binance Chain, now of course they've just rebranded. Binance Chain was optimized for decentralized trading, but it did not have smart contract capability. So then they came out with a new one, which is called Binance Smart Chain. So BSC, that is what all of us use. But now they've done a rebranding last few weeks, so they've changed the names. But basically, there are two blockchains, and now they're coming with a third blockchain. Now these are independent blockchains. They have different consensus mechanisms, but the native token across all is the same, which is the Binance coin or the BNB. Personally, it is my favorite as of right now. It's very cheap, very fast, easy to use, and fits natively into the MetaMask wallet, so it makes it much easier for you to do stuff. Any questions?
Not yet.
Okay. Then Cardano is another interesting one, but to be very honest, while it has an interesting algorithm, it is the only academically peer-to-peer reviewed blockchain. I am not seeing much uptick in terms of projects being built on it, so I'm kind of not very bullish on Cardano anymore. Then we have Cello. The great thing about it is it's the first and only mobile centric uh, blockchain. So It is trying to say that your mobile number can actually become like your blockchain address. And I would recommend, if the blockchain developers out here who have not tried it, try out Cello. It's a very interesting one, and I think in the long run it is going to do well because it's the only mobile centric kind of a blockchain. Any questions?
Nope, all
Okay.
good.
Then, of course, we have Ethereum, no doubt, the big daddy. Just remember, Ethereum is the protocol, mainnet is the actual public facing blockchain. You can fork it and make your own blockchain out of it. It's got a very, very vibrant ecosystem. When it comes to decentralized finance, Ethereum is the big boss. Even though it has a high transaction fee, what you must remember is Ethereum is for DeFi applications. It's got about $180 billion of TVL, total value locked. And the number two, which I think is Terra, is just about 18 billion. So there is this huge difference between the two. Ethereum is number one. And for big high value transactions, gas fee doesn't matter. So depending upon the application you're making, if the transactions are going to be low value, then don't use Ethereum. The gas fee is too high. Then you could consider using Binance, Avalanche, or even Terra. Any questions? All clear?
Nope, all good.
Okay. Then we have Phantom, another very good one, pretty popular in DeFi. Flow, I don't really see any unique differentiator. So I don't really think it'll do too well in the long run. I mean, there's nothing special in it. Polkadot, very interesting. It's not a blockchain, it's a network of blockchains, kind of similar to AVAX, but there is a difference here. You cannot go and create your own. The project creates parachains, parallel chains, and they auction it out. And the first round of auctions took place recently for millions and millions of dollars, and now they are slowly rolling out. So I think it's a little too expensive to get your own there. So you'd much rather use an AVAX rather than trying to use a Polkadot. Polygon, as we all know, started out as a scaling solution for Ethereum. That Ethereum is fast and costly, Polygon solves that problem. But Polygon is also its own blockchain. So I would recommend you could have a look at it. It's not just a scaling solution for Ethereum, it's an independent blockchain in itself. Very cheap, very fast. So you could highly consider using it. It underwent a name change early last year. So earlier it was called Matic, now it's called Polygon, but the token is still called Matic. Any questions?
Yes, we have some questions. So, someone has asked, are denial of service attacks a concern for all blockchain implementations?
Very good question. So
Mhm.
yes, so in fact, when we look at proof of work, and I would strongly recommend you have my look at my video on blockchain basics. I've talked about this. The concept of proof of work was not developed for blockchain. It was not developed in Bitcoin. It was actually developed for preventing distributed denial of service attacks and preventing email spam. Proof of work was made for that. And then the Bitcoin creators integrated proof of work inside to prevent this. So blockchains are vulnerable to this. Now, different blockchains handle DOS attacks in different ways. So a proof of stake blockchain would say that to make transactions, you have to pay money. To validate, you have to block up tokens. So economically, they are stopping that.
Mhm.
Now, Solana, which I'm going to talk about next, has been the victim of multiple DOS attacks. And in fact, there was a time, some time ago, when the entire blockchain went down for 16 hours. And that created a very big doubt. How can an entire blockchain go down? Blockchain has many nodes. You can launch a denial of service attack on one node, two nodes, 10 nodes. How did they do it on the entire blockchain? Which means it's highly centralized. If a blockchain is highly decentralized, a denial of service attack would not succeed. I hope that's clear. Hope that answers your
Yes,
question.
yes, that is clear. And just adding a point onto that, like, I remembered it happened onto the Ethereum as well, where the core team decided to reprice certain opcores because a team of attackers, like what they did, they created spam transactions onto the network in order to slow it down. So that's when they decided to actually reprice certain opcores to make it much more expensive to do these kinds of attacks.
Excellent.
And yes, there's one more question. Prathamesh has asked, like, in Shallow, like if they're exposing mobile number as an address, so isn't it a privacy concern for that user?
No, 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 don't worry. It is not actually exposing the number. But see, another thing you got to remember, Cello's vision is different. The vision is to make it blockchain based. So only if you send someone your number, they're going to send cryptos to you. It just kind of makes it easier for you to use your cell phone. You don't have to remember new addresses. So I think it's a good thing. If people have a privacy issue, then obviously they wouldn't use it. But I think it's a good thing if you can just give your mobile number instead of having to give addresses. Because if you end up giving the wrong address, or even if there's a copy pasting error, your crypto is gone. So I think it's much better to just give your phone number instead of an address.
Got it. Got it. Another question is some Shank is asking about how gas fees are such low on Polygon network.
Well, so actually, if you look at the thing, technologically, it's a little different how Polygon is made. So that also makes things cheaper because even Solana is so much cheaper. So that is one point of view. And secondly, all blockchains do not have that level of transactions also. The kind of transaction volume that they are handling. And then the TPSs are different. So automatically, if a blockchain has a high TPS, it can do more transactions in a block. So the transaction fee can be spread over a larger number of transactions, making it cheaper. But another thing I'd like to point out, recently Polygon also faced a big problem where suddenly their gas price spiked because of a new game which was released. Do you remember the name of that game? I cannot remember it. I think it was a
Uh,
farm related game. Recently, a new game was built, and that game produced so much load on the blockchain that the Polygon gas fee also spiked. So that problem is there even in Polygon. Yeah. Any other questions? Maybe in the meanwhile, if one of you could just Google it and tell us the name of that game. It happened just a few months back.
yeah, actually, I'm doing that.
Awesome,
Yes.
awesome.
All
Any
right.
other questions?
Okay, so Prathamesh is following up with this question regarding the mobile numbers as an address. So he's asking, instead of mobile numbers, can't we use some ENS service to
Yeah, you
point out
can.
to an address?
Yeah, you can, but then ENS service means now there's a separate fee that comes into the picture, another third party service being brought in. So, of course, you can do it, there's no doubt about it, but I don't know. I think it kind of defeats the whole purpose. I think it makes sense to either use a typical address system in which you can generate unlimited, or then a mobile kind of thing, which kind of reminds me of the UPI approach. But you're right, I mean, you could use ENS also. Any other questions?
Okay, so I guess the name is Sunflower Farmers.
Ah, I told you it was something to do with farm. Yeah,
Yes,
yeah.
right,
So,
yes.
how many X did it increase the Polygon fee? Is that also mentioned? It was a
Uh,
huge thing, I think.
yes, it is stating like by 16 times.
So imagine
Mhm.
16x the fee shot
Mhm.
up. Now the
Right.
problem in that approach is this can happen anytime, and your application may suddenly end up charging users so much fee and nobody realize what's happened. Which is why you've got to kind of take a very different approach to developing. So you always have to have multiple blockchains that can be used in your project, which is why API approach is better than building on one blockchain. Because if you build only on one blockchain and something happens like this, you cannot shift. But if you are using an independent API based service, you could actually instantly shift to another blockchain without breaking your code. Of course, there are problems in that approach also, but that's a good approach. I mean, it needs a deeper discussion to for me to explain that.
Right. And just a follow up on the like mobile numbers and all in a service. So it's like someone asking, like someone has pointed out, mobile numbers mapping means being dependent on mobile network operators, carriers. So that sounds more centralized and unreliable.
I think you know what we should do a separate session on cello.
Right. Yes.
Since a lot of you have found cello very interesting, I will
Mhm.
make a separate video for this and share it
That's
with you.
awesome.
Sure.
That's great.
Yeah. Then there is, of course, stacks. What it is trying to do is bring DeFi to Bitcoin. So now Bitcoin is the big daddy, most secure network, but it does not have a lot of DeFi capabilities. So kind of what Stacks is trying to do is bring a decentralized finance or a DeFi layer to Bitcoin. So I think it's an awesome project. Lightning Network is also kind of trying to do similar things. So in countries like El Salvador, where you can buy a McDonald's burger using Bitcoin, you obviously cannot push this transaction to the blockchain. Too costly, too slow. That is where Lightning Network and things like STX are coming in and solving it. And if they do well, I think Bitcoin could become one of the most popular DeFi platforms also. Stellar is the one of the oldest ones. It is from the Ripple team. At one time, it was phenomenal. I was a big fan of it, but now it's kind of redundant. I mean, what Stellar does is being done by so many other blockchains. So Stellar is kind of becoming not so popular, but it's a lovely platform. I haven't found any problems in it. The code runs very, very smoothly. They have their own decentralized exchange which they have built. It's a brilliant platform. Then there is Terra, whose native is Luna, and as of today, I think it is the number two in the world in terms of total value locked (TVL). After Ethereum, Terra comes second. Phenomenal platform. Tezos again, it's got nothing unique. It's just another decentralized platform out there, and same would be the case for Waves. I don't really use them anymore. I haven't found anything very unique and special. So if you guys are just starting your blockchain journey, naturally you must use Ethereum and learn it. Polygon, very important. Terra, very important. Avalanche, very important. Binance. So I would say this L is the one that you could start with. And then, of course, depending upon use cases, I need to know these 16 so that whatever use case my clients come with, I am able to advise them on which is the one which is correct.